Okay, so this is chapter 7. This is part 3. We're going to talk about the bone connective tissue, the microscopic bone tissue. Bone tissue is connective and it's made up of cells, and this material outside of the cells is called the matrix. Another way to say bone tissue is called osseous connective tissue, and you're going to see this prefix osteo many times within chapter 7 because it's talking about bone tissue. There are four. First, we're going to talk about the cells in the bone. 4 types: osteoprogenitor cells, osteoblasts, osteocytes, osteoclasts. Note that their prefix is all exactly the same. So to tell the difference between them, you got to look at the suffix. Progenitor, so they generate cells. Blasts, write down, they build. Is it going to work? Not work. But they build cells. Osteocytes are the mature cells. Write down the mature cells. And osteoclasts, they carve out bone. So I'll say it again. Blasts build bone. Osteocytes are the mature bone cells that maintain it. And osteoclasts, they carve out bone tissue. My internet is down. Hold on. Oh, I can fix it. Go me. All right. We're good. So osteoprogenitor cells are the stem cells. They generate other bone cells. They can develop into osteoblasts, underline osteoblasts. So osteoprogenitor cells can make more osteoblasts. And where do we find them? In the perosteum and the endosteum, like I talked about before. Osteoblasts, so form from osteoprogenitor cells, and they secrete osteoid. It's an initial semi-solid organic form of the bone matrix, and later it will calcify. So they're going to lay down the bone matrix. They're going to build the bone tissue. And eventually these osteoblasts will become trapped in the matrix that they make because the matrix is hard. So they're going to secrete it. And at first it's soft, but eventually it hardens, and then the bone cells are stuck. When they're stuck in the matrix, they are the mature bone cells, and they're called an osteocyte. So osteocytes are mature bone cells that are made from the osteoblasts. They maintain it, underline maintain the bone matrix. They keep it how it needs to be. That's Greta pounding on my door. They detect mechanical stress on the bone and communicate that to the nervous system. And they trigger the formation of new bone matrix. They can signal osteoblasts to do their work. So we've talked about osteoprogenitor that make osteoblasts that build the bone tissue, and they can become osteocytes, which are the mature bone cells that sit there and maintain it. The last type is the osteoclasts, and they're very different from the other 3. Come here, Greta. Come here. Come here. Come here. Hold this. Push it. Osteoclasts are large. They are phagocytic. Underline phagocytic. They break down the bone tissue, right, or carve it out. And they're actually derived a different way, or they're made from a different pathway. They have a ruffled border or little indents that increases the surface area for them to do their job. And they're involved in underlying bone reabsorption. They're going to carve out bone tissue when your body needs calcium. And here's an image that shows the progenitor, the blast, the osteocytes, and then the clasts. She wants to be a teacher. Yeah, she sees herself. So In the bone matrix, so we're talking outside the cells, there's inorganic components and there's organic. First, let's talk about the organic. The osteoblasts lay down what's called the osteoid and underlying collagen, and it contains, that's the organic part, collagen protein. Why do we need collagen in our bones? I thought it was only in our skin. It's going to give bones tensile strength, the ability to resist stretching. Bones are a little bit flexible. They have a little bit of give to them, and that is due to this collagen, this organic. The inorganic components are salt crystals, calcium phosphate right there. It can form, you don't need to worry about all these things, but they form these crystallized structures, calcium carbonate, sodium, magnesium sulfate, or other components of it. But they're going to be within the collagen. And why do we have these inorganic calcium phosphates? For hardened, more strength and rigidity of bones comes from the calcium. So the bones need to be in correct proportion of inorganic and organic, or collagen and calcium salts, to perform their optional functioning. If you don't have enough protein or not enough collagen, the bones are going to be too brittle. And if you don't have enough calcium, the bones are going to get too soft. So there needs to be a correct balance. Calcification, ossification, is the process of bone formation. When bone tissue is made after you break a bone or as you're growing, for example, it's going to begin with the laying down of this osteoid from the osteoblast. They're going to build the bone tissue. For bone tissue to develop or be done correctly, it requires these minerals and vitamins. Vitamin D is required because it absorbs calcium from the GI tract. Without calcium, we can't build bones. You need vitamin D for your bones to grow. Greta, can you get down? Get down. Yeah. Vitamin C is also required for bone growth. We talked about that in the tissues. Vitamin C is needed for proper collagen functioning. And we just learned that collagen is an organic constituent of bone. So you need vitamin C. And then you also need calcium and phosphate to form those inorganic components of the bone tissue. So that's building bone. You might not think, or it doesn't readily come to your mind, that it is important for your bone to break down at some points too. It's called bone reabsorption. An underlying osteoclast here. The osteoclast, they carve out the bone tissue. That's called bone reabsorption. So we're going to break down the bone to absorb the parts in it that your body needs. The osteoclasts contain these enzymes that are released from their lysosomes, and they chemically break down the organic components of that tissue, thus releasing calcium and phosphate. Your body needs calcium and phosphate ions to have your nerves function and have your muscles function. So when your calcium is low in the blood or phosphate is low, your nervous system will signal, or your hormones will signal your bones to break down bone tissue to release the calcium and the phosphates, which is amazing. This is a clinical view. Your book has a picture about osteitis deformans. It's when the balance of the osteoclast and osteoblast is not balanced. So what happens is there's too much bone breaking down, bone reabsorption, followed by a period of extensive bone deposition or laying down the bone tissue. So we're going to see these overgrowths of bone tissue, poorly formed bones in the pelvis, skull, vertebrae, femur, tibia are the most common areas. And then the symptoms, bone deformity. So we're going to see an overgrowth of bones. So it's going to look different. and there's also an intense amount of pain associated with that. We can show some pictures of some examples of that in class too. But think about the Hunchback of Notre Dame, for example. If you don't know who that is, look it up. So we've talked about the compact versus the spongy bone. There is some anatomy that's different between the two. Compact bone is made up of these cylindrical structures, okay, next to each other, very close together, called osteon. Another way to say that is called a Haversian system. Lisa wants to say hi. Okay. And they are the basic, these osteons are the basic component that make the compact bone, and they're arranged parallel to each other in the diaphysis, or that shaft of the bone. And it looks like a bullseye target. The middle of each one of them is called the central canal that contains blood vessels and nerves. Within it and around it, okay, so we have the central canal. Around it, you have this area called the concentric lamellae. It's the rings of connective tissue that surround that central canal that contains the collagen fibers that give the bones its strength. Within those lamellae, we're going to see little pockets of the cells, of the osteocytes, the mature cells. And they're, if you look closely, you'll find them. Make sure you look at the image here in a little bit. These are the mature cells. And the mature bone cells hang out in these little pods, I like to call them pods, or little spaces called lacuna within that bone matrix. So since the bones or the bone cells, the osteocytes are stuck there, and they need to communicate with other bone cells, how do they do that? They have these little extensions, interconnecting channels called the caniculi that connect the lacuna where the osteocytes sit, and then allows exchange of nutrients, minerals, gases, and waste between them. And here are some different images of the osteons, the central canal. These little black dots here, those are the osteocytes that are in their lacuna, or their little homes. Okay, so that's the osteons. Okay, that's enough, Lisa. Now let's talk about the other areas of the bone tissue that we need to know. Connecting the central canals that have the blood vessels this way is the perforating canals. They have blood vessels and nerves within them, and they're perpendicular to the central canals. And they're going to connect the different osteons together because they also need to communicate. We also have different types of lamellae. We have this concentric. We have circumferential. Fun word. On the exterior of the bone by the periosteum, and on the inside of the bone by the anostenum. The external and the internal. And then between every osteon, you have extra little lacuna called the interstitial. These are the leftover parts of the osteons that maybe have been degraded by the osteocytes. They've been partially reabsorbed, and their components have been used. So this is a great image. Make sure you pause here and locate all the parts of the osteon and all the other parts. And so you know what they are and where they're located. Here again, this is a cool picture of an osteocyte, that bone cell, mature bone cell that's stuck there in its little pod called a lacuna. The extensions of it called the caniculi. Kind of looks like little insects in the bone.